Welcome to the September edition of Corps Connection, the vlog from your U.S. Army Corps of Engineers, which takes you inside the castle and shows you what USACE is working on. I'm your host, Patrick Bloodgood. In this episode, we tag along with engineers from the Philadelphia and Los Angeles districts as they inspect a high-span bridge in Maryland. The Savannah district discovered some Revolutionary War-era artifacts in the Savannah River. They show us how they are preserving these relics. Our Engineering Research and Development Center is working on simulation programs to assist our combat fighters and how they navigate for amphibious landings. And the ERDC team is researching different materials and their strengths for applications in combat environments. We also give you a behind-the-scenes look at the USACE Unmanned Aerial Systems program as we fly with the Sacramento District. All those stories coming up on Corps Connection. Safety is always a main concern for the U.S. Army Corps of Engineers. For the Philadelphia District, which has the largest inventory of high-span bridges throughout the Corps, the job of ensuring these bridges are up to the task of safely handling thousands of vehicles per day is paramount. We spent the day with engineers as they take a detailed look at the Chesapeake City Bridge in Maryland to make sure it continues to be a safe and reliable means for vehicles to cross the Delaware and Chesapeake Canal. High above the Chesapeake and Delaware Canal, engineers with the U.S. Army Corps of Engineers load into lifts and other specialized equipment to get a close look at the Chesapeake City Bridge.
On the approach span, they have 5 floor beams.
The Philadelphia District is a USACE Center of Expertise for bridge inspection and evaluation. Within their area of responsibility alone, they have 11 bridges to look after, including 5 high-span bridges.
Every 2 years, we do an inspection on our 5 highway bridges, of which we have 150,000 crossings a day.
The engineers look above and below the bridge to see if there are any issues that need attention.
You're going to have a floor beam at each panel point. We go on the underbridge inspection vehicle, so that way we can go underneath and have an arm's length inspection of all the steel members. We use cameras, hammer if there are any corrosion, and we take photos and notes of all the deficiencies on the steel.
If the inspectors find an issue, they begin to work on a maintenance plan.
So based on the findings on the inspection, we can, if there are any repairs needed for the bridge, we can create plans and specs and then have future contracts do the repairs on the bridge.
It's through inspections like this that lead to maintenance like this. An 18-month, $45.8 million overhaul to the St. George's Bridge in Delaware, which is replacing the bridge decking, median barrier, as well as replacing bridge approaches and other structural features. The work the engineers do here also stretches beyond the Philadelphia District. As the center of expertise, they work with other districts to train their engineers, as well as perform bridge inspections within the other districts' borders. Los Angeles District Structural Engineer Leonard Tran is on site working closely with his Philadelphia counterparts to expand his bridge inspection knowledge.
These bridges right here are very unique, and then we don't have that in our district. So to be an effective team lead and for my district in the future, I would like to gain more experience, working on more variety of different bridges around the country.
Tran will also be taking his newly learned knowledge overseas when he deploys as part of a forward engineering support team.
I guess the purpose of going to this bridge inspection program is not only to benefit the LA district, but also benefit my FES team, as we're supposed to deploy in a few months. So one of my up orders to inspect the bridges in Europe.
Engineers say it can be a little disconcerting the first time they perform one of these inspections, but after a while it becomes second nature.
At first it's a little nerve-wracking, but you kind of get used to it after a while. Yeah, it's not too bad. It's definitely high up, but you get a nice view out of it.
The ultimate goal of the inspection program is to keep these vital pieces of infrastructure throughout the nation safe for all who use them.
So these inspections are very important because it's the Chief of Engineers' highest priorities, as well as mine, is life safety.
Well, it is a big responsibility because we are inspecting this bridge here that thousands of people drive over every day, and we are taking care of their lives.
From Chesapeake City, Maryland, Patrick Bloodgood. The city of Savannah is a historic southern city, and its waterway, the Savannah River, holds treasures few have ever seen. A few of these treasures turned up recently when the river's navigation channel was being dredged.
Let's say you've discovered more than a dozen Revolutionary War cannon at the bottom of a brackish river and lifted them up out of the water. What do you do next? One thing's for sure, doing nothing will destroy the artifacts.
If you take material out of the sea and you don't do anything to conserve it, it'll deteriorate very quickly.
That's why when archaeologists from Chronicle Heritage, under contract to the U.S. Army Corps of Engineers, recovered 19 guns from a 1779 shipwreck in Savannah, Georgia, they sent 17 of them to this facility in Texas to be conserved.
Well, Texas A&M has a world-class conservation lab for such sites, and so through a competitive contracting process, they were selected to do the conservation for this project.
This facility is the Conservation Research Laboratory. We call it the CRL. We are one of the larger and older conservation facilities that focuses on materials from underwater archaeological sites. There's not too many facilities out there that have the equipment and the expertise that we do. Any material that comes off of an underwater archaeological site or terrestrial site, we can conserve here.
Restoring these cannon for display is a complex, multi-step process. The most urgent requirement is to put the iron artifacts into a special bath that removes salts and stabilizes the metal.
So what we're doing is we're taking the cannon and we're putting them into a vat, filling that vat up with an electrolyte. In this case, it's sodium hydroxide, and we're creating a circuit. So we're putting DC current into the cannon, and then what it does is it pushes the salts out of the metal. It takes a really long time, upwards of, it could be 2 years in some cases to get all the salts out, but it's an effective way to get the salts out.
The cannon come out of the vats for a short time so they can be unloaded. After more than 200 years underwater, there's no danger of the black powder inside exploding, but it's still important to remove the objects placed into the barrels before they were sunk. Step 1 is removing the wooden plug, called a tampion, that seals the opening.
When these cannons sank, they were loaded and they still had a plug in the end of them. So these are still plugged up the way they were when they went down.
Next, you need to pull out a lump of old ropes called the junk wad, which sailors stuffed into the barrel to keep out moisture and keep their powder dry. Then, if you're lucky, the cannonballs roll right out. 1 or even 2.
This is a 6-pound cannonball.
And there's another one right behind it, as per usual.
Then another junk wad, and finally the remains of the bag of black powder all the way in the back. All the contents removed from the cannon are carefully measured and photographed by the archaeology students who work at the lab, and each type of artifact requires its own special tender loving care.
Treating the paper for the charge bag, for instance, is a completely different process than we'd have to do for the iron. Different materials break down in seawater in different ways.
The powder bags, made of 2-century-old paper, are especially rare and required the team to create a custom conservation protocol.
This is not something that survives very often, so we got really lucky on this. There's not very many examples of this known. And so what we're doing is they're between sheets of paper with blotting paper on top, so we can do a slow, controlled dry.
Elsewhere in the lab, archaeology grad student Alyssa Carpenter and a colleague use a noisy pneumatic device called an air scribe to chisel away things that have stuck onto the outside of the cannon during the centuries submerged in the dark, salty water.
It's a really crazy feeling because when you get a cannon that hasn't been worked on, there are like mud globs over it. There's a lot of like mollusks and biological activity, and so when we're scraping it with an air scribe or with a hammer and then you hit the surface, it's a crazy feeling because you're the first one to see the surface. And so we just keep doing that, and we have no idea what we're going to find. And that's kind of like the joy of it.
It's dirty, smelly work from beginning to end, but the team members uncover more than just iron, rope, and paper. They also find a satisfaction that's hard to put into words.
There it is.
Ooh, okay.
working on these cannons, it's kind of emotional because I am descendant. I'm a descendant from like people who fought in the Revolutionary War in the South. And to me, that's just crazy that I'm working on these cannons that they could have touched. It's just a whole experience, especially when you see the cannonballs and the junk wads roll out and you're the first one to hold them.
It's starting to hiss.
I remember when I was the first one, John took the cannonballs out and I just didn't think about it. I took them and I was gonna weigh them. And then like walking to the scale, I had all this gunpowder dripping on my hands and I just stood there and my hands were shaking a little bit and I realized I'm the first one to hold these and weigh them on a scale.
It's impossible to not be thrilled to be doing this kind of work. It's the ultimate behind the museum glass job, right? We're getting everything secure, so when it goes to the museum, everyone can go and see it and enjoy it. But it's a very satisfying feeling to know that you're the person that's helping preserve these for generations to come. It's really cool.
It will take another year or two to finish the work. Then these 17 cannon will be sent back to Georgia to be reunited with 2 unconserved guns already on exhibit at Savannah History Museum. In the meantime, archival research continues alongside the physical conservation efforts.
It seems like every week or every month, as we get more information, it reveals more and more about the site. It's a process. We're embracing it. We're enjoying just the journey of uncovering whatever we can about this shipwreck.
Reporting from the Conservation Research Lab at Texas A&M University, I'm Michael Jordan for the U.S. Army Corps of Engineers, Savannah District.
The Army Corps of Engineers Engineering Research and Development Center is working to push the limits and capabilities of different types of materials. The center is researching the items to help and find the best possible solution for reinforcing aging facilities, as well as the next generation of buildings and equipment.
The focus area of my group is to synthesize novel and affordable 2D material systems, including graphene-related materials, and determine their structure, property, processing relationships, and optimize those to be able to obtain the best performing materials. As a chemist, my hands are in a wide range of research topics, from concrete hydration modeling to advanced composites to modular protective systems and 2D material systems, including graphene-related material. At ERDC, all of our applications are to benefit both civilian and the military side. It's really incredible. So in terms of military, we have Army modernization priorities and priority research. So my work directly relates to all those areas. And in addition, we have a number of civilian applications going on, from water filtration to military application. So it all ties into all those areas nicely. In terms of the applications of all this work, can be counted in a number of ways. Infrastructure is the big one, because we have structures aging that need to be addressed, and we also need to have resilient infrastructures for our future. So those are extremely important for us. The other one is in the advanced composite area. So we try to come up with what is the true interaction between different layers, let's say multi-layers. How can we enhance those for specific applications geared towards either military or civilian use? The infrastructure includes buildings, bridges, roads, all those asphalt pavements, any type of structure we use for our daily lives as civilians, or the structures that need to be used for military purposes. So ERDC is trying to identify what areas deserve the most research. It's also important for us to be able to come up with the most novel, affordable materials, so we can improve the impact of graphene addition into our cementitious matrices compared to just regular concrete.
ERDC's Coastal and Hydraulic Laboratory is home to USACE's Ship Simulator, which is used to evaluate bay channels across the globe and assists with planning out ship movements for proposed navigation channel improvements. Recently, the team has developed a mobile version of the simulator for military applications.
Tom McKenna and I came down for a visit in about 2015 and wanted to know if the ship simulator could be used for military applications. And it's been a huge success. We now have a facility that's at the secret level. We can do all types of amphibious landings and assault operations, and we actually bring in operators from the military to actually drive the simulator, which is very important. It gives us feedback on how well the simulator behaves in real life, and we get really good feedback for our employees on how we can move forward with the operations that we do.
We decided that we were going to turn around and provide a portable ship simulator capability to the Army watercraft and the DoD watercraft community writ large to be able to provide mission analysis, mission preparedness in terms of mission planning, and then to do mission rehearsal to determine the feasibility of the particular operation and to be able to measure its success both from an operator perspective as well as from a commander's perspective. The particular event that we were able to participate here, the MISPIX 23, these types of events provide to a much larger audience that we would normally be able to do by going to an individual unit. My goal here and the goal of the team is to turn around and take the capability and understanding the forces from the physical environment, whether that's tide, whether that's the current, wind, wave, the terrain itself. What we're doing is giving them the opportunity to assess, hey, you got to go do this mission, and give them the ability to assess, can I actually make the mission occur within the parameters that have been defined?
In getting to meet all these different people and hearing their comments on how helpful this would be for them is really good for us to take back to where we build these scenarios and can help them accomplish what they need to accomplish to protect our country and to keep them safe in whatever part of the world they're in. Is really good.
So really what makes Arctic unique is the people. I mean, you can walk into a variety of simulators throughout the country and the equipment's going to look fairly similar. But it's the people, it's the lens they look through. So you from the engineers like myself or the computer scientists, in addition to we have an amphibious warfare expert. So you bring those entities together and those experts, that's what really provides the value, because you know the equipment's going to be the same. But it's actually the analysis after the fact that you get. In the words of a recent visitor to Arctic, it's going to help make our soldiers more lethal, and it's also going to make sure we can bring more of them home alive.
Simulators are great because you can throw all kinds of things at them that may be not available that day for weather. Maybe you're going to say, hey, we're in really bad sea states. Well, you can actually dial that in here and actually do it for real, simulate it. So I think it's overall a great planning tool.
We make a lot of fairy dust assumptions sometimes about it'll take 21 days, we're going to be ashore and everything's going to be ashore. I think this is a great session because I had no idea this kind of tool existed. So I don't know if other people did, in the actual military, but I think that it was really beneficial to get this kind of information out that either the military or organizations like mine can use to help the military do their planning and modeling and not recreate the wheel of something that already exists.
This is the start of any operation on that beach. What I like about this is that you had different weather conditions in there. So right now you got rain with like probably 3 foot, 5 foot waves and crosswinds and whatnot, which you really don't want to do that in a training scenario. But you do that in a simulator, now you have training and perspective on weather conditions, which you really won't get out there, and that's going to be very helpful for folks that just won't get that opportunity.
It does give me an opportunity to see what other ways to test, to experience and participate in those operation planning scenarios. So when we do have an actual scenario, we know how to practice it, exercise it, and stuff like that, which is very important. And a lot of people won't know what's out there unless, you attend conferences like this. With every operation, regardless whether it's a combat environment or non-hostile environment, or you will have casualties. Accidents happen, especially when you're moving ship to shore movement. There's a lot of safety situations involved. So yes, again, this scenario, this simulator can contribute to that. It does give you a different perspective on how to conduct planning. It does allow you to, you know, in your mind, observe the scenario and come up with different courses of actions on how to implement the certain scenario that you're trying to solve.
This is a great opportunity for vessel masters and crews to be able to kind of get a real world picture of an area that they're going to be going to. It's portable, so this can go anywhere. So we have vessels all around the world. We're operating missions all around the world. There's a big difference between here and Hawaii. Hawaii, you have a lot of the trade winds. It's a predominantly windy area. So a vessel master or crew coming from Virginia, where the wind usually isn't too bad. It's not a big factor that we have to deal with when docking or undocking the vessel. Then you go to Hawaii, it's a whole new experience. So utilizing this, they can get the training and experience that without actually putting any equipment or personnel in harm's way.
Unmanned aerial systems, or as some may call them drones, have become a major advancement for the U.S. Army Corps of Engineers. Whether it is for surveying beaches, creating 3D models of existing facilities, or simply some really cool aerial imagery of our projects, the UAS teams at USACE continue to use platforms to help reduce cost and increase safety in gathering vital data and imagery. The Sacramento District takes us behind the scenes of their program and the strict regulations that they must abide by.
This is Luke Burns, a remote pilot with the U.S. Army Corps of Engineers aviation team. Today, Luke navigates a small, unmanned aircraft over the American River, capturing aerial footage of the ongoing levee improvements. This substantial federal infrastructure project is designed to fortify flood defenses for the adjacent communities in Sacramento. However, piloting for the Army Corps of Engineers isn't simply about choosing a good spot and taking to the air. These infrastructure projects are funded by Congress, partner agencies, and taxpayers. So pilots like Luke shoulder an additional layer of responsibility. They are bound by stringent local airspace, Federal Aviation Administration, and Army aviation regulations. In preparing for this mission, Luke meticulously built a mission plan, assessing the airspace for potential impact to nearby structures like airports, schools, and homes. Additionally, he performs a daily risk assessment, maintains a flight log, reviews a safety checklist, and thoroughly inspects the aircraft before flight. Yet, Luke isn't alone in this. Every Army Corps of Engineers unmanned aerial mission requires a team of at least 2 crew members, a remote pilot, and a visual observer. Though the flight process and requirements may seem intensive, it is necessary. These are big projects with far-reaching impacts, ultimately serving our communities and the nation. The U.S. Army Corps of Engineers aviation team is committed to flying legally, safely, and effectively. To delve deeper into our program and watch the latest captivating aerial videos of our projects, please visit our website or social media.
That completes this episode of Core Connection. So as the warm summer breezes fade and the kids are back to school, remember, USACE continues to serve our nation and its warfighters. Until next time, this has been Core Connection.